In this video, we'll look at how to rationalize denominators. So first off, what do we mean when we say rationalize a denominator? Well, when we rationalize denominators, we want to rid the denominator of any radicals and also have a purely real number in the denominator. So I want basically an integer in the denominator that's also real. So let's look at how to do that. Well, if we have the square root of 18 over the square root of 8 plus 5, and we're asked to simplify, we have to first off simplify any radicals, and then we're going to rationalize the denominator. So in order to do that, let's first simplify radicals. The square root of 18 can be rewritten as the square root of 3 times the square root of 2 over 2 root 2 plus 5, because 8 can be rewritten as 2 root 2. Now, if we want to rationalize the denominator, we have to write it so that we don't have a radical in the denominator. Right now we have a radical, we have 2 root 2, and that's a radical. So we want to somehow get it so that there's only an integer in the denominator. So the way to do that, well, in the last video we looked at when you multiply conjugates and you have a plus b times a minus b, well, that's equal to a squared minus b squared. So let's see what happens if I multiply 2 root 2 plus 5 times its conjugate, and I can multiply the numerator and denominator by the same number, and that's essentially equivalent to multiplying by 1. So I'll have to multiply the numerator by 2 root 2. This should be 2 root 2 minus 5, because that's the conjugate. 2 root 2 minus 5 is the conjugate of 2 root 2 plus 5. So now let's go ahead and expand this. Well, in the numerator, I should put brackets here in the numerator and denominator. And I can really think of there as being brackets here. Well, in the numerator, I'm just going to distribute 3 root 2 into the brackets. So if I multiply 3 root 2 times 2 root 2, I'll get 6 times 2 root 2 squared, which is 6 times 2. So that gives 6 times 2 is 12. And then I'll have minus 15 root 2. Because 3 root 2 times negative 5 is negative 15 root 2. In the denominator, I'll have 2 root 2 times, remember that I'm multiplying conjugates here. So if I multiply a plus b times a minus b, that's equivalent to a squared minus b squared. Instead of a here, I've got 2 root 2. So I'll do 2 root 2 squared. And instead of b, I've got 5. So I'll have 2 root 2 squared minus 5 squared. And the numerator I can't simplify. So I'll have 12 minus 15 root 2. 2 root 2 squared is 8. Because I'll square 2, which is 4, and then I'll multiply that by root 2 squared. Root 2 squared is just 2. So 4 times 2 is 8. If I square 5, I get 25. So I've got 8 minus 25, which is negative 17. Now, there's a nicer way to write this, because right now I've got the negative assigned to the denominator. But I can generally, if I have a negative in the denominator, I want to assign it to the numerator. So let's go ahead and do that. Well, if I want to think about this as positive 17, and I assign the negative to the numerator, well, this can be written as, if I distribute the negative into the numerator, I get 15 root 2 minus 12 over 17. So 12 minus 15 root 2 over negative 17 is the same as 15 root 2 minus 12 over 17. Let's look at another example. Here we have root 12 plus 1 over 2 root 5 minus root 7. So again, we're going to try to simplify any radicals and then rationalize the denominator. So first off, let's rewrite this as, root 12 can be rewritten as 2 root 3 plus 1 over 2 root 5 minus the square root of 7. Now, we want to try to rationalize the denominator in order to simplify this, so we're going to multiply both the numerator and denominator by the conjugate of 2 root 5 minus root 7, which is 2 root 5 plus root 7. And we're going to do the same thing. We have to multiply the numerator by the same thing, because effectively what we're doing here is multiplying by 1, because I can't change the value of this expression. If I were to just multiply the denominator by 2 root 5 plus root 7, then I would change the value, and this number wouldn't be equivalent to the number that I would get, essentially. So I have to multiply both the numerator and denominator by the same number, and that's essentially multiplying by 1. So let's go ahead and expand the numerator. Well, here I've got a product of two binomials, and I've got to FOIL this. So I've got to multiply this term times this term times this term, and then I'll multiply these two terms, and lastly, these two terms. So if I do that, I get 2 root 3 times 2 root 5, which is 4 root 15. Then I multiply 2 root 3 times root 7, which is plus 2 root 21. Next, I've got 1 times 2 root 5, which is just 2 root 5. And lastly, I've got plus 1 times root 7, which is just plus root 7. In the denominator, I'm multiplying conjugates, so my product is going to be a squared minus b squared. And I'm going to get 2 root 5 squared minus root 7 squared. Well, in the numerator, now I'm going to just simplify. In the numerator, I can't reduce any of these radicals, nor can I add them together, because none of the terms are like terms. So my numerator will just stay as is, and I've got 4 root 15 plus 2 root 21 plus 2 root 5 plus root 7. All over, well, 2 root 5 squared is 4 times 5. Because when I square 2, I get 4. When I square root 5, I get 5. So I'll get 4 times 5, which is 20. And minus root 7 squared, well, I'll have 20 minus 7, which is 13. So this is equal to 4 root 15 plus 2 root 21 plus 2 root 5 plus root 7. Over 13. And notice that now I've got a denominator in both of these examples that are integers. I've rationalized the denominator. In the next video, we'll look at how to rationalize denominators that are imaginary, or complex rather. See you in the next video.